Hi all, welcome back. In this video, we are discussing the PLC ladder logic programming on problem 3. The problem statement is like this. Draw relay ladder diagram for following sequential operations. Start button pressed. Table motor started. Package moves to the position of the limit switch and stops. Auxiliary features required are emergency stop, red light to indicate stop condition, and green light to indicate package moving condition. Draw input and output connections diagrams also. So this problem is on a conveyor or a material handling device. The picture shows the system. So here we have got a motor and a conveyor system, and on that this one is the package. So when switch S is switched on, the motor starts rotating and the conveyor starts moving in this direction. So it will carry the package in this direction. So when the package reaches at a location where we have employed the limit switch, it stops. Then we are employing an emergency switch to stop the system as and when required. Then there is a green light to indicate the package moving condition, that is the running condition of the motor, and a red light is also employed for indicating the stop condition of the motor and the stop condition of the package. So the required ladder logic program can be drawn like this. So when we press S1, S1 will open, S1 will close. Okay, so it start conducting. Since this LS1 is in normally closed condition, so it will also conduct the electricity. So this relay R1 is switched on. So once relay R1 is switched on, this switch from R1 is also switched on. So we can have the latching over here. So that latching will hold the R1 on. So from that R1 we are connecting. Here is also normally opened one, and when the R1 relay is charged, this one is a relay. So when R1 relay is charged, this one is also get opened. So the green light will glow. And on the other hand, we are using a normally closed switch from R1 to connect with the red light. This RL is representing the red light. So when R1 is charging or R1 is switched on, this will be changing from normally closed to open. So it is now not conducting. So the red light will switch off. And another switch from R1 is taken, and that is also a normally open switch. And when R1 is switched on, this will also become closed and it will start conducting, and the motor is switched on. So that is the first part of the program. And when it reaches the limit switch, when the package reaches the limit switch, so the limit switch is get on, so then it will be converted from this normally closed position to normally open position. Now it is now open, so the circuit breaks, so the R1 relay is also switched off. Once the R1 relay switched off, the green light will switch off, and here it is normally closed one. So when it is off, it is again closing, so it will switch on the red light. So the motor stationary condition indicated by the red light, and the motor is also switched off. That is the working, and now the sequence is established. Now the additional thing we have done is providing an emergency switch in the circuit, and whenever there is a problem or whenever we need to stop this entire system, we have to press the emergency switch. Emergency switch is a normally opened switch, and whenever it is pressing, it will become sorry, it is a normally closed switch. Whenever it is pressing, it will become open, so it will cut the electricity or power to the entire system. Now the system is on, switched off condition. Here it shows the input connection and output connection diagrams. In input connection diagram, we are connecting an emergency switch to the input, then switch S1 for starting the system, and a limit switch 1, which is normally closed to 1. This is also normally closed to 1. This one is normally open to 1. That is the input connection diagram. And the output connection diagram, we have got three outputs. That is, one is motor, which is connected, and there is a green light, and the light is symbol is like this. So green light is connected like this, and also we are connecting a red light. So we have got three outputs. By this, the problem 3 is solved, and thank you for watching.